Welcome back to the deep dive. Today we are taking a really fascinating and I think very necessary shortcut right into the architecture of modern security operations.
Mhm.
You sent us material that dives deep into how these centralized systems handle just massive amounts of security data.
That's right. And while the source material itself is, it's geared toward the certification exam,
Hmm,
the knowledge points we're pulling out are pure architectural gold.
absolutely.
We're looking at the engine that handles logs from, it could be hundreds of devices, and turns gigabytes of raw traffic into actual definitive security intelligence.
Right. So our mission today is pretty clear. We're translating that very technical structure into, well, strategic insight. How does a massive security platform guarantee data integrity when a network fails?
Or how do you keep client A's data separate from client B's?
Exactly. And the big one, how do you automate the response when a compromise is actually detected?
And we can navigate this whole terrain by focusing on four key areas. First, we've got the really crucial data management and segregation concepts, the plumbing, basically.
Performing, I like that.
Then we'll get into the actual mechanics of log analysis and threat hunting. Third, we'll explore the huge efficiency gains you get from SOC automation.
And then finally,
And finally, how all that work gets packaged into clear, compelling reports that, business leaders can actually understand. So let's start with that plumbing.
okay, let's do it. When you're dealing with a large organization, or maybe you're a managed security service provider, an MSSP, you can't just dump all the logs into one giant pool.
No, absolutely not. You need structure.
You need structure, which brings us to administrative domains or ADOMs. From an architectural view, what are the two, let's say, non-negotiable benefits these things provide?
The benefits are really dual layered. You've got security and then you have operational control. For security, for governance, ADOMs give you that necessary segregation.
Yeah.
They build a digital fence, if you will, around the log data and the admin access for different customers or departments.
So Department A can only see Department A's data.
Exactly. It's a classic separation of duties, paramount.
That makes perfect sense. What's the second benefit?
The second one is really about resource constraints. So ADOMs let you apply different disk log quotas to different groups of devices.
Oh, that's smart. So if one department is super noisy.
Right. If one department has extremely high traffic and generates, say, 20 times more logs than another, you can cap their storage usage.
So they don't starve everyone else of resources.
Precisely. It prevents them from consuming the entire platform's resources. It's essential resource management at a very basic level.
Okay, so let's talk about a major administrative pain point this architecture can introduce. Let's say an organization merges, and suddenly you have to move a whole bunch of devices from ADOM A to ADOM B.
Right. A common scenario.
The sources say the database for that device must be rebuilt for the new ADOM. Why? That sounds like a massive administrative headache.
It is a huge constraint, and it really highlights a critical architectural trade-off. The rebuild is mandatory because the system has to ensure the device's entire historical log data.
Everything it's ever generated.
Everything. Everything from before the move. It has to be reliably included in reports and searches within the new ADOM structure.
So the logs are indexed based on their ADOM.
Exactly. They aren't just rows in a spreadsheet. They're organized. They're indexed based on their ADOM affiliation. If you don't rebuild that structure, that historical context is just gone.
So years of security data could become basically useless for compliance or an investigation.
It could become inaccessible, yeah, or unusable under the new domain structure. It's a big deal.
So the immediate win of having these tightly segregated resource-controlled databases comes at the cost of agility. That's a huge strategic implication.
Absolutely. Now, moving on from organization to resilience, we have to talk about data loss prevention. Security logs are evidence. You can't lose them.
Not an option, no. Even if the network drops for a few minutes.
So how does the system make sure logs are never lost if the connection between the security device and the central analyzer fails?
Well, that is the beauty of log buffering. I like to think of it like a mailroom.
Okay.
If the connection between the source, say, a FortiGate firewall, and the central FortiAnalyzer system goes down temporarily, the sending device, it doesn't just throw away the mail.
It holds onto it.
It holds onto it. It has a built-in mechanism that temporarily caches or buffers those logs right there on the device locally.
And then once the connection comes back up,
As soon as it's restored, it automatically detects the server is back online, and it just forwards the entire queue of buffered logs.
it's the ultimate store and forward mechanism. It's a crucial safety net for maintaining the integrity of that forensic trail.
Okay, so that covers the plumbing and the resilience. Which brings us to the next challenge, finding the needle in that gigantic data haystack.
Right. Once all these logs are safely ingested, how do you balance the need for, lightning-fast, real-time analysis versus digging through years of archived history?
A constant battle.
And it's defined by two very different tools, quick search and full search. Quick search is all about speed, performance.
Okay.
It looks through the fast indexed log database, the hot data you could call it, usually the most recent logs.
So that's for what just happened 5 minutes ago.
Exactly. Your immediate tactical analysis.
Yeah.
But, the reality is that most complex investigations, they require looking back 6 months, maybe longer.
6 years even, and that's where the performance trade-off really hits you.
Correct. When you need to get to those older logs, you are forced to use full search. It's required to access the non-indexed archive logs, the cold data.
And because it's not indexed, it's slow.
It takes significantly longer because the system has to manually sift through all that historical data, but it's the only way to guarantee you access everything. You're trading speed for depth.
So this is where the architecture really starts to get smart, turning raw data into intelligence. We have a dedicated feature for this, the Indicators of Compromise Service, or IOC.
The IOC service.
What is its fundamental tactical purpose?
The IOC service is your proactive threat radar. Its whole purpose is to scan incoming logs in near real time and rapidly compare elements inside those logs.
Like what kind of elements?
Things like IP addresses, known malicious domains, suspicious URLs, file hashes, that kind of thing. It compares them against a constantly updated list of known threats from intelligence feeds.
So instead of an analyst hunting through logs, hoping to spot a bad IP from some bulletin they read last week,
Right.
the system itself is basically shouting, hey, alert, we just saw a known threat actor's domain in our traffic right now.
Exactly. It just dramatically accelerates the time between exposure and detection. It completely shifts the analyst's job from sifting through noise to immediately investigating confirmed high-confidence alerts.
And speaking of acceleration, that brings us to automation in the Security Operations Center, the SOC.
The power of automation, yeah.
Because if every time the IOC service raises an alert, a human has to manually check logs, open a ticket, email a manager, block an IP, the whole system just grinds to a halt.
It doesn't scale.
It doesn't scale. This is where playbooks come in. When a manager asks, why are we spending so much time on these playbooks? What is the strategic primary goal we should point to?
The primary goal of a playbook is to eliminate human inconsistency and error. It does that by automating a whole sequence of response actions when a specific event happens.
A sequence, so not just one action.
Not just one action, no. The beauty isn't just that it does one thing quickly, but that it ensures the entire multi-step response workflow runs smoothly and identically every single time.
Without anyone needing to touch it.
Or without any manual intervention. It's security orchestration for consistent incident handling. It's the difference between hoping 10 different analysts all follow the same procedure versus guaranteeing one automated process executes flawlessly.
And the trigger for these playbooks, that's the event handler, right?
Precisely. The event handler is that initial trigger. When it detects a suspicious pattern, it's designed to kick off immediate reactions. And our sources highlight two critical, distinct actions it can take.
Okay, what are they?
So first, the most basic action is just communicative. It can send an email alert directly to an administrator.
Fast, simple notification.
Fast, low overhead. But the second action is more formal, and I think more critical for the workflow. It creates an incident in the SOC tracking view.
And why is that distinction so important? An email versus an incident?
Because the email is just a ping. It's a notification. The incident creation, that elevates the alert from just a log event to a formal investigation ticket.
Ah, so it has a life cycle.
It has a life cycle, an assignment, required follow-up. It immediately integrates that detection into the broader organizational workflow. It demands action.
Okay, that makes perfect sense. And that sets us up for our final segment, taking all this collected, organized, analyzed data and actually presenting it to people.
Yep, reports, the final product of all that complex infrastructure.
So let's use a common scenario. A security director wants a specific custom report. Let's say the top 10 riskiest users report.
A classic.
And they want it delivered to their inbox automatically every Monday morning at 8 a.m. What 2 features are absolutely necessary to make that happen?
To get that specific outcome, you need 2 architectural components working together. First, you need a custom report.
That defines what the report looks like.
Exactly. Defines the look, the feel, the charts, the data that's needed to compile the top 10 riskiest users' info. Second, you need the report scheduler.
And that's the automation piece.
That's the automation piece. It's responsible for automatically generating that custom report and emailing it out on that preset schedule. It eliminates all the manual effort.
So custom report is the what, scheduler is the when and to whom.
Perfectly put.
Yeah.
Now, this brings up a really crucial and often misunderstood point. Reports rely on data sets.
Right. Most people just see the pretty charts.
They see the colorful bar charts and pie graphs, but underneath all of that visualization is the data set. What actually is it?
The data set it's really the hidden engine of the report, isn't it? It's the specific query that pulls the data from the database.
Think of it like a complex SQL query.
Yeah. It defines the exact log tables to look at, the fields to select like source IP, username, action, and the filters to apply.
Only show denied traffic or only activity from this user group.
Right. And if your data set is poorly written, your report is going to show garbage.
Exactly. It doesn't matter how beautiful the chart looks. The data set is the intelligence filter that decides what makes it out of that raw log swamp and into a digestible report.
Okay, excellent. Let's wrap up with a practical troubleshooting nugget for administrators. Suppose logs from a device suddenly just stop arriving.
The sysadmin's nightmare.
They check the config, they check network traffic, everything seems fine. Our source material points to one specific feature that is the least likely reason for this log ingestion failure. What is it?
This is a classic test of understanding data collection versus data display. The least likely reason for missing logs is that the log view feature has been disabled.
And why is that?
Because disabling the log view only affects how the logs are displayed to the admin in the user interface.
Ah, so it doesn't stop the collection.
It has zero impact on the actual background process of log ingestion, collection, and storage. The data is still coming in.
So real failures are things like a wrong port, a firewall block.
Or, critically, the disk quota is full and the system is configured to just stop logging when it hits that capacity.
So you might not see the logs, but they are still being collected. If you disable the view, you are, in effect, just blinding yourself to data that's still flowing in.
Precisely.
So what does this all really mean for you, the listener? We've just taken a very rapid, but I think deep dive into the operational backbone of security intelligence. We looked at how ADOMs manage segmentation, the administrative cost of those changes, how log buffering guarantees data integrity, and that critical difference between quick search and full search.
And, of course, how playbooks enforce consistency through powerful automation.
So if we connect this to the bigger picture, all these highly technical details, they really reveal that effective rapid security intelligence is built on two pillars.
I'd say those are highly organized, even rigid data storage and smart, flexible automation. The infrastructure has to be resilient enough for billions of logs, yet agile enough for an immediate automated response.
And thinking about that necessary rigidity, the need to rebuild a database just to move a device between ADOMs to keep that historical access.
Or the performance hit of using full search for the archive logs.
Exactly. It highlights this permanent architectural trade-off in security monitoring. It really raises a question. When you're designing your next system, how heavily should you weigh immediate operational performance, that lightning-fast, quick search capability, versus the long-term, accessible data history that you absolutely need for forensics and compliance? It's a tension that I think managers and architects face every single day.